Day 536 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3347, maximum frequency of an element after performing operations 2. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums and two integers k and num operations. You must perform an operation num operation times on nums where in each operation you select an index I that was not selected in any previous operations and add an integer in the range of -k up to k to nums of I. Return the maximum possible frequency of any element in nums after performing the operations. All right, y'all. So that sounds pretty simple, but let's take a look at these examples just to make sure that we are doing this problem correctly. Now, the first thing we want to do is we want to see what they mean by frequency. It says the frequency of an element x is the number of times it occurs in the array. So, for example, in this array, each element has a frequency of 1. So 1 appears once, 4 appears once, and 5 appears once, as opposed to this array where we have an element that appears twice, right? We have two 20s. 20 appears twice, so 20 has a frequency of 2, while 5 has a frequency of 1, and 11 has a frequency of 1 as well. Now that we know what a frequency is, let's get into example 1. So in example 1, we have the input nums equals an array of integers 1, 4, 5, k equals 1, num operations equals 2. The output is 2. The explanation says we can achieve a maximum frequency of 2 by adding 0 to nums of 1, after which nums of 1 still stays the same, 1, 4, and 5, and adding -1 to nums of 2, after which nums becomes 1, 4, and 4. So let's break that down one step further, right? So what we want to do is we want to find the maximum possible frequency of any element in nums after performing the operation. So we want to create an element and that will now have the maximum possible frequency using these operations right here. So and we also have to use two operations because num operations is 2, so that means we can only do 2 operations. K equals 1, so that means we can either subtract 1, add 0, or add 1 to each element in this array to try to make an element have the maximum number of frequency or occur the maximum amount of times. So in this case, they decided to add 0 to nums of 1. So after that, nums of 1 will be 4. So 4 stays the same because we add 0 to it, but that uses 1 operation. So we only have 1 operation left. Then they add -1 to nums of 2, after which this 5 right here, after adding -1 to it, it becomes 4. So now 4 has a frequency of 2 as opposed to 1 having a frequency of just 1. So now that 4 has a frequency of 2, that means 4 has the maximum frequency, which is 2. So that means we return our output as 2 because 2 is the frequency of the element that has the maximum frequency. So just in case that didn't make sense to y'all, let's take a look at example 2. Example 2, same principles apply. So in example 2, we have the input nums equals an array of integers 5, 11, 20, and 20. K equals 5, num operations equals 1. So this means we can subtract up to 5 and we can add up to 5 on any one of these elements in the array. So, but we can only do one operation, so we can only do that one time. The explanation says we can achieve a maximum frequency of 2 by adding 0 to nums of 1. So as you can see, 20 already has a frequency of 2, 5 has a frequency of, 5 has a frequency of 1, and 11 has a frequency of 1. And as you can see, even if we added 5 to 5, it still wouldn't be 20, right? So it'd be 10. 10 would still only have a frequency of 1. And even if we subtracted up to 5 from 11, the lowest we could get was 6. And if we got to 6, 6 would still only have a frequency of 1. And there would be two 20s over here still. So no matter what we do, 2 is still going to be the maximum frequency because of these two 20s over here. So the output is 2 because 2 is the maximum frequency, or out of all of the frequencies in this array, 2 is the highest. 20 occurs 2 times. So that's why we return 2. Boom. So now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all. So let's get into it. Now, the first thing we are going to do is we're just going to get nums.count by coming over here, and we're going to say let n equal nums.count. Boom. Then, sorry, y'all. Then we're going to just check to see if it's an empty array, because if it is, then that means there is no frequency possible. So we're just going to come right here, and we can say if n equals 0, then we can just return 0. Boom, just like that. Let me clean this up for y'all. Sorry about that. Boom. Now we need to build a frequency map of all of the numbers in nums. And this is going to tell us how many times each number already exists without any operation. So first we're going to declare a variable called freq. We're going to say colon. That's going to be a dictionary. The key is going to be an integer. Then we'll say colon. The value is going to be an integer as well. And we will initialize it with a blank dictionary just like so. Boom. Then we're going to say for v in nums, open up the brackets. We're going to say freq square bracket v, comma, default, colon, 0. Then we're going to say plus equals 1. So each time we see an element v in nums, each time we see that element, we're going to start counting that element from 0. So the default value that we start counting from is going to be 0. And each time we see that element, we're going to add 1 to it in this dictionary. Boom. Then we're going to come underneath this, and we're going to create a list of events for a sweep line algorithm. Each number can be transformed into any value within a through k, and a to negative k and a to k. We'll treat each range as an interval and use events to track starts and ends. So we're going to come right here, declare a variable called events. We're going to say colon, open up the brackets, open up the parentheses. We're going to say POS colon, int, comma, DE delta, colon, then we're going to say int, boom, and we're just going to initialize it with a blank dictionary. Boom. Then we're going to say events dot reserve capacity, open up the parentheses, and we're going to say 2 times n, just like that. Then we're going to come underneath this, and we're going to say for a n nums. We're going to open up the brackets, and we are going to say let start equal a minus k, where the range is going to start. And we're going to say let end equal a plus k, which is where the range is going to end. Then we're going to say events dot append, open up the parentheses, start, comma, 1. So we're going to, it's going to be plus 1 when the interval starts, and we're going to do negative 1 after the interval ends. So to do that, we're going to say events dot append, open up the parentheses, end plus 1, comma, negative 1, just like that. Now we need to collect all of the candidates' target values. We'll check for max frequency. This is because the overlap count may change as the range boundaries start and end, or an actual number in nums. Checking all other points will be redundant. So we could come right here, and we can say declare variable called candidates set. We're going to set that equal to a set less than int. Boom, and put the parentheses just like this. Boom. Then we're going to say for a in nums, open up the brackets. We're going to say candidates set dot insert, open up the parentheses a. Then we're going to say candidates set dot insert, open up the parentheses a minus k. Then we're going to do it one more time. We're going to say candidates set dot insert, open up the parentheses, except this time we're going to say a plus k. Boom. Then we're going to come underneath this for loop. We're going to say var candidates. We're going to set that equal to an array, open up the parentheses, and pass in candidates set, just like that. Now we're going to sort both the events for sweeping and the candidates for iteration order. So come underneath this, we're going to say events dot sort, open up the brackets. We're going to say if $0 dot POS equals $1 dot POS. We're going to open up the brackets and we are going to say return $0 dot delta is greater than $1 dot delta. Boom. Then we can come underneath this and we are going to say return $0 dot POS is less than $1 dot POS, just like that. Boom. Then we come underneath this events dot sort and we're going to say candidates dot sort and put the parentheses. Now we need to sweep through candidates while maintaining the current overlap count, and the overlap is equal to the number of ranges that currently cover the position X. So we're going to come underneath this, declare a variable called overlap, set that equal to 0. We're going to declare another variable called EI and set that equal to 0 as well, and declare another variable called max freak achieved, and we're going to set that equal to 0 as well. Boom. Then we're going to say for X and candidates. We're going to open up the brackets and we're going to apply all interval events whose position is less than or equal to the current X, and this is going to update overlap to reflect how many elements could reach X. So we're going to say while EI is less than events dot count and two and signs events square bracket EI, come outside the square bracket dot POS is less than or equal to X. Then we're going to open up the brackets and we're going to say overlap plus equals events square bracket EI, come outside of that square bracket, say dot delta, come underneath that, say EI plus equals 1. Boom. Now we need to compute how many numbers are already equal to X, meaning there's no operation needed, so we can declare a constant underneath this while by saying let existing equal, set that equal to freak square bracket X, and it's optional, so put question mark 0. Boom. Then we're going to count how many other numbers can reach X but aren't equal yet. We're going to say let reachable but not equal. We're going to set that equal to the max. Open up the parentheses. We're going to say 0, comma, overlap minus existing equal. Then we can only perform at most num operation conversions, so we take as many reachable but not equal numbers as allowed by coming underneath this, and we're going to say let achievable equal, set that equal to existing equal plus min, open up the parentheses, num operations, comma, reachable but not equal. Boom. And then we're going to track the highest frequency achievable for any candidate X by coming underneath this, and we're going to say if achievable, say less than max freak achieved, then we're going to open up the brackets and we're going to say max freak achieved equals, we're going to set that equal to achievable. Boom, just like that. And then finally, last but not least, we need to return the maximum possible frequency after performing all of the operations by coming right here. And all we have to do is say return max freak achieved. Boom, y'all. That should be all she wrote. I know it was a lot, but we got through it. Let's run it. Make sure it runs correctly. So they cannot find events and escape where we at. Why can I not find events in scope? Well, we need to change this to an S. Or we need to add an S, I should say. Boom. So now let's see. Okay. Instant method append expects a single parameter. Now, one moment, y'all. Well, I see what do they mean. This is, let me see, y'all. Okay, so somewhere it says events. Let's, oh, where it's getting sorted. Okay, so maybe that should do the trick. Now let's run it. See if that did the trick. Okay. Still did not do the trick. Let's see what else we have here. Cannot find candidates in scope. Let me see, where is that? So, boom, let's add this E. Let's run it again. Let's see what else we got. We got all these typos. Again, how do I keep doing that? Let me see. Let me see, y'all. Where is this even at? Oh, right here. Boom, let's run it again. Typos after typos. Sorry, y'all. Let's see what happens. Okay, let's see. Cannot find achievable in scope either. Where is this achievable at? So which, well, first let's come back up here, I guess, and let's see what's going on here. Let me see, y'all. Let me see. Okay. Oh, this needs to be wrapped in parentheses as well. like that. Now let's run it, and hopefully it will tell us where our achievable error is. Okay, let's see, where is that? Right here. So let's see, I'm gonna just it's this right here. Boom, y'all. That should be it. Now let's run it. Sorry about that. It's a lot of code, but it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 350 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, make sure you get one more look at the code. This is the top part. This is the middle. And this is the bottom. And yeah, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.